Alright, to approach the problem, we first had to pull up the Vpython programming lab to discover what units our inputs would be in. And since you said in class everything had to be in radians, we also had to add the conversion formula from degrees over to radians. And then our first major section was to identify our objects, which you will see in the video as being the green and red sphere. We had to address them properly so the thread would become true, and then we had to define the volumes of the X and Y components, and we did the same exact thing for the sphere that deals with the air resistance. Then we had to define the time interval of time in gravity, which is the negative 9.81 times mass times seconds squared. And then we put the velocity of the balls into the vector unit notation since it's easier than putting it in polar form. And the easiest way to tackle this problem was by using loops. So dealing with the first component, we wasn't dealing with X, so everything was in Y. So we had to define the formula just by using Y. And we stopped the ball at 0, which was the breaking point of it. And then to find the equation for the one with air resistance, we pretty much did the same thing as we did on the first sphere, except we had to use the velocity of the drag of the X and Y, but pretty much everything still was the same. And yeah, but with this one, since it deals with X now, because it got the air resistance, we had to put the little line that shows how far it goes, so you know where it stopped. And let me run it.